This video is on esters and polymers. Esters are made of carboxylic acids and also alcohols. For example, if I have an ethanoic acid here, meaning 2 carbons, and one of it is a COOH, and an alcohol, the simplest alcohol, let's say methanol, and a reversible arrow here because it's a reversible reaction. It will form the ester, and there'll be a loss of a small molecule of water, which is why it's a condensation reaction. Now, to make the reaction favor the right-hand side, we will want to remove this water. So we need to put sulfuric acid as a catalyst. This is a dehydrating agent. Part of the ester comes from the carboxylic acid, and part of it comes from the alcohol. So this makes CH3, COO, CH3. So the water came from OH here and a H here. So this went to the water. To name an ester, we'll name the alcohol portion of it first. So this is a met, 1 carbon, so methyl. So eel, and the front is a carboxylic acid here. So there's 2 carbons, we will name it eth. So ethanoate. So we name it by O8 for the carboxylic acid side of the ester. Let's look at some other examples. Say if the question is in this condensed structural formula, it will be easier if you display it and you'll make less careless mistakes. So I'm going to display this. CH3, CH2, CO, OH. Making sure that each of these carbons have 4 bonds. Each of the oxygen should have 2 bonds, and all the hydrogens should have 1 bond. Same as what we did just now. I'm going to take the OH from here to make the water, and the H from here that makes H2O. Since I'm displaying it, so it goes this way, my equation. All I need to do is copy from the carboxylic acid. There's 3 carbons there. And then I shall copy this portion. I need the O to be on this carbon. So the O is attached to a CH2. It's sort of flipped to the other side. And a CH3. So your job is to make sure they are connected to the correct atoms. So CH3, CH2, CO, and this O will always attach to this CO carbon. So just remember that. Let's look at a more complicated example. Ethanoic acid with butan 2-ol. So I make it a little bit complicated here so that you will understand it a little bit deeper. Okay, COOH here. Plus butan 2-ol. 1, 2, 3, 4. And then OH on the second carbon. So OH from the carboxylic acid and H from the alcohol. We get water here, that's for sure. And we're going to copy the carboxylic acid. And the O must be attached to this carbon. And we've got to copy everything attached to it. So attached to this O is a CH. A CH. Attached to this carbon is a CH CH3. I'll put it up here. And a CH2, CH3. I'm going to put it down here. Did you see that I flipped it something like 90 degrees so that it's more convenient for me to draw the ester? So this is an ester. If you see R, COOR, then it's an ester. To name these esters, we take the alcohol side, that's it, 2 carbons, so ethyl, and 3 carbons here, so propanoate. And this one, number 2, carbon number 2 has this O, so 2-butyl ethanoate. Next, polymers. We'll cover 2 types of polymers, the addition type and condensation. So condensation will look similar to what we just did just now, the esterification. Addition polymerization, the monomers are alkenes. It must contain a double bond at least. And it's on the double bond site that it will polymerize. So what's this polymer? Polymer is a really large molecule that is formed from small little molecules, and those small little molecules, they are called monomers, as in like one of it. And when there's a lot of it, then it's poly. Okay, example, ethene is a monomer. And I can polymerize ethene. Now to understand this, let's look at these bonds as electrons. So there's 1, 2, 3, 4 electrons. When it polymerizes, what happens to it is that this electron goes to this side to bond with something on its left. And this electron goes to the right to form with something on the right side. Okay, so what's going to happen? Well, the product, one of the bonds are gone. That's because it's going to the right and the left to form with the other monomers. And so there's a single bond here instead of a double bond. The double bond's gone. And the electron went here. Say I have another one more of ethene here, and it's going to do the same thing as the first ethene. So that this electron came from here, and this electron came from here. So this double bond is gone as well. Now this is a single bond, and this is just a single bond now. And so this is 2 repeat units of polyalkene here. So it's a polyethene. There's 2 repeat units of the ethene. 1, 2. I can go on forever. I can continue here because it's a polymer. So this would be the next ethene. And the next ethene. So each of these ethene provide an electron to the left and to the right to continue this chain. So polyethylene is a synthetic polymer, meaning we can make it in the lab or in a factory. And there are natural polymers such as your hair, nails. These are from keratin. And then from your skin, bones, there's collagen. So these are natural polymers. Let's look at some other examples of these addition polymers. So instead of a polyethylene, this time I'm going to draw a propene so that you will understand this more. We'll always focus on the double bond. So don't be confused about the other carbon here. So the other carbon, when you write this in exams, it doesn't play a role. So you just need to copy this CH3. So our focus is always the carbons that's having the double bond. So we're going to do that again. There's these 2 orange colored carbons. I'm going to draw 2 repeat units. So carbon, 1 repeat unit, orange carbons, 2 repeat units. Now where is this CH3? 3 here. Let's keep that blue so that you can see the difference. Okay, that CH3 is on one of the carbons. It's on this carbon. So I'm going to write this here, CH3. And then this again, and another CH3, so CH3. Okay, now I'm going to fill in all the rest of the H. Put a bracket here. And put a bracket here. So this is 1 repeat unit. This is 2 repeat unit. This is polypropene because there's 3 carbons. Let's see 2 more examples, polybut-1-in and polybut-2-in. So but-1-in looks like this. The double bond is on the first carbon. And there's 4 carbons of the but. Okay, check that all your carbons have 4 bonds. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And polybut-2-in. So I'm going to draw the monomer first. 1, 2, 3, 4. And the double bond is on the second carbon here. I'm just going to complete that. Remember, I told you to focus on the carbon that is double bonded. So these 2 carbons and these 2 carbons are our main focus. I'm going to draw 2 repeat units. And 2 repeat units here. So these carbons here are these 2 carbons. Okay, so we're going to repeat this twice. So 1, 2, 3, 4. Let's see what's attached to it. This carbon has 2H. The second carbon has 1H only. And it has a CH2CH3. And we said it's a repeat unit, right? So we're going to repeat this carbon again. So 2H and then a H and CH2CH3. Now I just want to demonstrate that this can flip around. So I can exchange these 2 carbons. So it can be, look at my arrows, okay? It can be 1, 2, 3, and 4. That's exactly what I'm going to do. So 1, 2, 3, and 4. So 3, I said it's this carbon, right? So I'm going to put the H here this time and CH2CH3 here. And the last carbon would be this one, so CH2. So what I can see here is this is 1 repeat unit of a but-1-in, and this is a second repeat unit of another but-1-in. So this is how it works. Next, 1, 2, 3, 4. They're identical. This carbon is attached to a H and a CH3. And this carbon is the same. It's attached to a H and a CH3. So I'm just going to keep repeating that. A H and a CH3. Oh, I don't have enough place to draw that. I'm going to put the CH3 on top. It makes no difference. You can do that. Top and bottom is the same thing. So I'm going to just alternate that so that I have more space to draw if it's in my exam paper. And therefore, this is 1 unit of that but-2-in, and this is another unit of the but-2-in. Where's my but-2-in? It's actually 1, 2, 3, 4. That's your but-2-in. Okay, more examples. Chloroethene. So chloroethene looks like this. Remember, I told you you can flip You can flip this 180 degrees. So I'm going to draw a random polymer here. So the first one has the Cl. I'll put a bracket here. Okay, this is 1 unit of the chloroethene and it's attached to the next chloroethene. I'm going to flip it around. So this side HH and this side Cl. Okay, but remember this, you can't get something like this. So this is wrong. But why is this wrong? So how to check? This is 1 unit, you have 1 Cl there. This is 1 unit, you have a Cl there. This is wrong, there's 2 Cls. So one of that has to be a H, whichever. So this has to be a H. That's how you check whether your polymer structure is correct or not. Okay, what's a phenylethene or a styrene? Styrene looks like this. So for now, you just need to know how to draw this hexagon shaped thing and the circle in the middle. That's a benzene ring. The concept is the same. So if I'm going to draw 3 repeat units, so in every 2 carbons, I should have that ring on one of the carbons. So it could be the left one or the right one. It's up to you. So I'm going to start off with one that is without it, one with it. The next repeat unit, it's up to you. I'm going to draw an identical one. And third one, I'm going to flip it and draw the hexagon thing, benzene ring on this side. So this works. So make sure every 2 carbons, there is only one of this ring. Next, condensation polymerization. Now this condensation polymerization works almost exactly like the esterification that I showed you just now earlier in this video. So one of the molecules will have to provide the H and the other molecule has to provide the OH to form the water. Okay, besides water, it can also eliminate a HCl molecule. So one of the molecules will have to provide the H and the other molecule have to provide the Cl. So where do they come from? I'm going to draw a table here. To provide the H, we've got alcohol. We've seen that. And besides alcohol, under polymerization, the other thing that can provide a H would be NH2. So we'll take one of the H out. And to provide the OH or the Cl, it's the carboxylic acid just now. So we'll take this out. Or COCl, we'll take this Cl out. So it can form water or HCl. Water or HCl. Let's have a look at this example of nylon. So we're going to eliminate H from here. That's from this H2. And there's a COCl here. We're going to eliminate this. And after we eliminate, then this N is going to bond to this carbon. Okay, let's draw that. So the H has been eliminated. I'm just going to copy the rest and H, and there's 1, 2, 3, 4, 5, 6. So CH2, CH2, CH2. That's 3 of them. 4, 5, 6. And one of the H is taken out. This N is going to be connected to this carbon because the Cl has been taken out. And there's 4 CH2s. CO here and bracket because the HCl, the Cl has been taken out to form HCl. So this is 1 repeat unit. There's no repetition. Like after this carbon, there's no N again, so nothing repeated here. So this is just 1 repeat unit. Where it bonds on the CONH, this is called the amide linkage. So therefore, nylon is polyamide. CONH is an amide. It's a functional group. More examples here. This is a pterylene. We have this benzene 1,4-dicarboxylic acid. We don't have to know what is all this complicated things in between. We only need to look at a functional group that we're going to use, which is the OH, that's for the water, the OH to make the water, and H to make the water, and H to make the water. So this O is going to be linked here. Okay, let's do that. CO, this is hanging. Copy everything. Oops. Might I remind you that this is a common careless mistake. Please remember to draw your O here because we only take out the H here. The O is still there. We took the O from this side, from the COOH. So the O is still here. Okay, that is one repeat unit. So nothing repeated here. This is one repeat unit. Okay, if I want to draw two repeat units, let me change the color. So let's continue from here again. So we're just repeating. I will just copy everything all over again, and that is called two repeat units. There you go, two repeat units. So one here and another repeat unit here. We have we've drawn four monomers here. One of it, two monomers, three monomers, and four monomers are used to form this polymer. Okay, but remember this is just two repeat units because each of this repetition has two of these monomers. If you look closely here, this is RCOOR. Here, RCOOR. Same goes here, RCOOR. So RCOOR, that's an ester. So this is an ester link. This is an ester link. I'm going to erase the rest of the arrows. So those with the arrows, they are the ester link. Some polymers, they can polymerize with itself. So just repeat many of this. As long as it has two functional groups that can be polymerized. So there's the OH here and the COOH here. So these are the functional groups that we need to polymerize. But we may want to redraw this so that the alcohol and the carboxylic acid are at the terminal carbons, and we'll shift the other stuff to the top and bottom. So if I were to display this for your convenience, you see the OH is at the bottom, so I don't want that OH to be at the bottom because it's difficult to draw in exams. So I'm going to put this OH on this side and switch the CH3 down. And we're going to polymerize with this OH here. Okay, I'll redraw that first. So H, here I'll put the CH3. It is the same if I put the OH here, because I need this H later. And COOH, I need this OH. Okay, let's polymerize that. One repeat unit. So I start here. O, C, CH3, simplify that. CO. And that's it. Connect to the next one. I'll repeat this O, CH, CH3, CO, bracket. This is 2 repeat units. So let's look at this. 1 repeat unit, 2 repeat units. This is my ester link. And water has been eliminated. It depends how many monomers you have here. You can calculate how many water molecules have been eliminated. I'm going to end this here. Then I would only have 1 water. But if I carry on and make 1 more repeat unit to be connected here. So repeat this again, O, H, CH3, CO. And then I complete it with an OH. Then I would have 2 water molecules. Now it's balanced.